Good morning. I'm Carol Ann Logue here in Orlando, Florida at the Central Florida Tech Grove. Thank you so much for joining us this morning for the this is April edition of our NTSA Tech Grove Connect. This webinar series that we do for several months during the year highlights the story, the team, the innovation embodied in the best papers and tutorials from the most recent ITSIC. So we're very glad you joined us this morning. I want to take a few minutes just to tell you a little bit about the Central Florida Tech Grove for those of you that are not familiar with us. I'm sure many of you on this call are familiar with the fact that Department of Defense funds a lot of innovation initiatives and programs out there. Many people are familiar with AFWorks, DefenseWorks, SoftWorks, CyberWorks, all those works out there, right? That are all doing wonderfully innovative, rapid acquisition work. We fit in that same community of Department of Defense funded innovation centers. We are focused, as you can see on the slide there on the screen, we are focused specifically on human performance, modeling, simulation, and training. If you're not aware of it, Orlando, Florida is the heartbeat, if you will, of the Department of Defense's acquisition and a lot of R&D that goes on for human performance modeling, simulation, and training for the services, and an amazing cluster of companies, extraordinary academic work that goes on here. What makes us, well, not just a little, but truly unique among all of the defense innovation units out there is that we are funded by 5 of the DoD services. You see the logos down there along the bottom. So Army, Navy, Air Force, Marine Corps, and Space Force are all helping support, fund Tech Grove, actively work through us individually and collectively together jointly, which builds on the longstanding collaboration here known as Team Orlando. This is our lane, if you will. Many of you on this webinar today are in the areas of human performance training and simulation, so you know that those phrases encompass a lot of enabling technologies and capabilities. That's what you see along the bottom down there. As many of the audiences we're speaking to are not in this space yet. They're not doing business with the Department of Defense, and we are working very diligently to bring innovators, academics, even other government partners into this space with their cutting edge technologies to help grow the defense industry base, because that is one of our missions too. I look forward to all of you being involved with us if you're not already. You see this list of events that we do. There's actually more that aren't even on there. Most of what we do is hybrid, so no matter where you are, you can join us virtually for almost everything that we do. There are just a few things that are completely in person, but be sure you follow us on LinkedIn, Facebook, Twitter, any of those platforms. You'll find information about our event. You can check our homepage, which I will tell you by Monday of next week, we will be launching a completely new revamped website that will have a lot more robust information on it and ways for you to interact with us. And you can always email us and ask us for information. And these are just some of the upcoming events that we have going on. Monday, our Innovation Harvest Day, highlighting 16 early stage innovative companies from across Central Florida. Our active prize challenge right now, we'd love for all of you to go check that out. It's on challenge.gov, and that'll take you to the link with the full information about the prize challenge, tackling a very critical front-end problem in interoperability in live virtual constructive training scenarios. So check that out. Check out our other events, and we look forward to seeing you either virtually or in person here in Tech Grove in the future, again, or for the first time. And with that, we're going to move into the real part of this webinar, which is the team that was behind the best paper at ITSIC on adaptive learning. And we have with us today our 2 experts here, Dr. Summer Rebensky from Aptima Corporation, and she is out of the Dayton, Ohio office. And so they do a lot of work with AFRL, and Summer was previously with the Gaming Research Integration for Learning Laboratory, known as GRIL, there at the Air Force. And also Jonathan Diemunsch, who is a computer scientist with GRIL. So they are going to share with us the work that they've done in adaptive learning. We had a lot of questions from those of you that registered today, and we will get to as many of them as we possibly can. We won't get to all of them, and some of them will be answered during the presentation, and we'll address some of the others afterwards. I'm also going to put a link to the actual paper in the chat for you in case you haven't already gone and found that. So with that, Summer, Jonathan, welcome. We're so glad to have you here today for the Tech Connect. And I know you're going to start into your presentation here and talk a little bit about the GRIL Lab, and then you're going to talk about your work in adaptive learning, both what was embodied in the paper, but also we always want to know when we have guests on our Tech Connect program, what have you done since then? Because that paper was submitted a good while ago. It was last December, and they've not stopped working on it. Plus, how could those of you that are with us today engage with them? What do they need to continue the wonderful work that they're doing on this very important area of training and simulation? Summer, Jonathan, it's all yours.
Thank you very much for having me. Sorry, we didn't discuss who was getting introduced herself first. So I'm Jonathan Diemunsch. I'm a computer scientist at the GRIL. There was a bit of a misspeak there. Summer is with the GRIL at the Air Force Research Lab. We're both with the GRIL. So I'll let Summer introduce herself, and then I'm going to talk a little bit about the GRIL, our mission, what we do, how you guys can engage with us, and then I'll have Summer talk a little bit more specific about some of the challenges that the paper tackled and was talking about. So Summer, if you want to introduce yourself before I start.
Awesome. So my name is Dr. Summer Rebensky. As Carol introduced, I work for Aptima Inc. as a research scientist. A lot of my research spans many different things, from adaptive training to gamification to using AR, VR tech to modernize training. And so a lot of the questions that we saw submitted kind of touch quite a few of these little areas, as well as how do we measure performance and be able to really build out adaptive training. So I'm hoping to give you guys a bit of a tidbits of that. There's a lot more information in the paper, and we only have 1 hour, so we're hoping to cover as much as we can today. Jonathan, go ahead and take it away.
All right, wonderful. All right, wonderful. So the GRIL has a 2-part mission, and it is leveraging commercial off-the-shelf game tech and using that to solve Air Force training challenges. And then the other half of it is STEM outreach. The gaming industry is massive. Everybody knows this. There's no surprise to anybody here. And STEM outreach is extremely important for growing our future workforce. So what we're always looking for is how can we use the latest technology, whatever it is, primarily game tech, but it doesn't have to be game tech, to make better training. And then we want to take what we make and show it off to kids to get them excited to come in and be the next me, be the next Summer, be the next everybody here. We're going to need them, right? All of them, we want them to be excited in this about this sort of the sort of fields, right? So we have our local impact for our STEM program leverages the staff, which are primarily government and contractors. But then we also have work with the AFRL Scholar Program. And underneath that, there's a program called Right Scholars. That's where we have about 15 or so high school students. They're either juniors going into senior year or seniors going into college. And during that summer, we have 9 weeks, and we have them come in. Give them a challenge problem, and we say, go solve it. We are always looking for people to partner with on these challenge problems, because we want to be the mentors for the technical expertise. So if they want to ask us, how do you populate an array, we'll tell you how to do that. But if you want to know, how should I build this? What design decisions should I make? Well, you need to talk to the customer. So we love having customers, external, give us their gaps, give us their challenges, and then we give those to the kids to address. So to answer your first question, the best way to get involved with the grill is to have gaps or challenges that you can submit to us as challenge problems. They don't cost the end user, the partner, anything, because the Right Scholar program is paid for by educational outreach, and we're paid for by AFRL. So the end prototypes that come out of this are free to the customer. So that's one of the easiest low-hanging fruit. But we do have, on top of that, we hire some summer interns. We bring in teachers and PhD researchers into this program as well. And all of this comes together to develop these prototypes and challenge problem, solve the challenge problems, and deliver part task trainers for researchers and curriculum for teachers. So for the military and government side, it's kind of similar, but a little bit different in the way that we get our impact, right? So we have our team, but we also work with all sorts of other teams all over the place, trying to help leverage our experience and knowledge to solve problems. So during the summer, it's all about, the kids, but great, we can come up with prototypes, but we want to make sure that the kids learn a lot and are inspired to go into STEM fields. Through the rest of the year, that's where our focus is on developing technologies that can be really useful to solve actual training gaps, which is where this DART testbed kind of came out of. So one thing I just want to show before I move too far away from the STEM stuff is this has been our growth over the years of our summer STEM program. And as you can see, every year it's been growing. It didn't even slow down during COVID, which not many people can say that. And so we're always looking for new partners for that, and always looking for new challenge problems. So now we get into some of the design stuff for the actual sim for the test bed. And so I'm going to talk a little bit about the technical side, and then I'm going to pass these slides over to Summer to talk a little bit more about the research side, because that's kind of the two sides of the same coin that we work here at the Grill. Is we do the research, but we also do the development. So some of the questions that I got ahead of time,
Jonathan, sorry, I am going to interrupt you here though, because since we have quite a few people on the audience, I think it might be helpful just to give a common framework and if you two would just give a definition of adaptive learning or adaptive training, in the context of your work, how do you define what adaptive training is? I think that might be helpful.
Yeah, of course. So when we talk about adaptive training, it's really providing the end trainee an individualized experience. What works for me isn't necessarily going to work for everyone else who's out there. And we get trainees that have different experience backgrounds, they have different skills, they have different proficiencies. And so how can we leverage this technology to give people the exact right experience for them? A lot of research out there shows that if we're able to put trainees in what they call the zone of proximal development, or in a flow state, which is where the content that they're receiving is just a little bit more challenging than their skill level, we can really see higher training gains. If we put them in a scenario that is too difficult for training, they can tend to disengage. They may not perform as well. They can get pretty discouraged. But if we give them scenarios that are far too easy, what we'll end up seeing is trainees also become disengaged and are pretty bored. And we're not using the limited training time we have in the most effective way because they're already proficient at those skills. So what we're looking to do is really explore how we can do this within a game engine in a more individualized approach, moving to a sort of live adaptive environment.
And there's just also to kind of help set the stage here, I think you touch on it in your presentation, but there have been some barriers to adopting and using adaptive training to this point, still are, right? And my understanding is that's part of what's driving your work to take a game design approach, correct?
Exactly. In order for us to really build an effective adaptive simulator, we need to know fundamentally what are the skills we're trying to train. That's already a key piece there. Are there skills and competencies that we can actually measure within a at least simulation training environment? How do we classify and collect those? How do we determine what's too little, too much adaptation? When do we do it to where it's not basically jarring for the trainee, or do it too little to where we could have intervened sooner? There are so many moving parts and levers that knowing where to start and the best way to do it can be really difficult.
Thank you. Jonathan, apologize for interrupting you, but I thought it might help to just put that context there. So thank you.
Yeah, no, it's all good. It's all good. So I'm gonna give again a little bit of technical. We got kind of a list of questions I'm gonna try to hit while I talk about the technical side of this, and then Summer can talk to the research goals, which again is that adaptive training and how can we change the simulation that you're in to best suit you, the trainee. So this was developed in Unreal Engine using a couple of different sensors. One of them is a chest-mounted biosensor, and then another one was a head-mounted biosensor. The head-mounted was the NearSense, and then the chest-mounted was the Summer, can you help me? I can't remember the name of it.
It's called the NearSense. I'm going to go ahead and move along to the slide because it'll help you to explain a little bit.
Are they both NearSense?
One is called the Polar H10 and one is called
that's
the NearSense.
That's the one I was thinking of. Okay, so we use the Unreal Engine. We use game engines primarily because of the flexibility. They handle a lot of the heavy lifting for physics and animation, and you can rapidly prototype things in them. We're using Unreal Engine because it's specifically designed to be able to take in 1,000 different types of controllers and just use them, right, without any question, and you don't have to do any work on the programming side to bring them in. So it makes it easier for us to integrate new technologies because as time goes on, it just handles more and more technologies that exist. So we've been using game-based training for a little over a decade now, and we find that it is a great way to prototype out systems to show the art of the possible. We also find that the game-based systems can give you a real good sense of whether or not what you're doing is headed in the right direction. Sometimes using a game engine in the long run isn't the way you want to go, but usually for the first pass to get an idea of what is technically possible, we find that it's a major cost saver. Let's see, any other ones on here I want to hit before I move on? So one other thing that I don't think we have any slides for that I want to hit before we get back and I turn it over to the research side is that at the Grill, we bring in a lot of different technologies, and we're always looking at how we can use and leverage game engines. One of the things we did and have been doing for the last couple of years is developing plugins for the latest game engines to integrate into larger Air Force simulations. So we have an open source plugin called UE4DIS, or there's a Unity to DIS plugin that we generated, and it can work with Unreal Engine 4, 5, or Unity. It uses the OpenDIS libraries to allow you to program stuff in a game engine and then output and import DIS entities into your simulation. It's been a great tool to put out there, and then we've had a lot of downloads because it's a it's a free stealth viewer for your simulation. So if you want to see what planes are flying where and who's doing what, you can just download our example project, run it, and you already have a stealth viewer. You don't have to make any edits. So we find that this is really useful to allow people to develop things in game engines for Air Force simulation, whereas without these sort of integrated tools, it's a barrier to using game engines. Then you would have to develop this on your own in your own sim somewhere. So those are some of the major technical things that some of the challenges we've tried to overcome, and some of the things that we use in our game engine or in our lab, and how we leverage game engines. Primarily, this is written in Unreal Engine. We use Unreal Engine a lot because it has better resolution, it has better look, and so we find that it's easier to get to a more polished looking product with Unreal Engine, and it has a language called Blueprints that it utilizes. I see somebody posted up in the chat, how do we get access to the DIS plugin? I can post a link up here, but if you go on GitHub and Google it, I'm sure you can find it on your own without my help. It's freely available. Yeah, so that's some of the technical side, some technical details, and I'll pass over to Summer. If there's any more questions for me, we can get back to those later.
Awesome. So this project and this effort kind of stemmed from an existing simulator that was within the grill that was aiming to look at cognitive workload. And so it was a driving-based study that allowed you to elicit cognitive workload, kind of look at some sensor technologies and measure people as they went through this task. What we wanted to do was elevate that and see if we could create a live adaptive environment. So we started to delve in some of the adaptive research out there and identify different methods and gaps so that we could design this test bed to be able to address some of those pain points and open research areas. Within the paper, there's a pretty good review of adaptive strategies and styles. I'm going to hit them just a little bit here and then go into some of the benefits of using game-based engines to iterate on adaptive training designs and our instantiation of a form of that. So I'm sure many of you have customers or are customers yourselves who have said, I want to build in adaptive training into my system, and you have no idea where to start. So first, it's how do I ultimately adapt? Now, we see two different kinds of strategies out there. One is macro. If you're an instructor, you'll often see instructors do this on their day-to-day basis. We have things like remedial and advanced classes in the civilian world. You may also give some of your trainees a unit test, and you see that there are certain concepts that the trainees aren't really grasping, and you decide to go back over that content in more detail. As humans, you may be already doing some form of adaptive training and not even know it yourself. There's benefits to doing that at the classroom level, as you're able to do it as an instructor on the fly. It's pretty low cost, easy to do, but you're not getting it to that individual level. So you also have these micro level strategies, which you look at the individual person. Some of those strategies can focus on delivering someone content, and once they do an assessment test, you may determine that they need to go back over certain material, or that they can advance to more difficult material, or there's particular concepts they weren't getting, and so they'll get exposed to more content. That works a lot within computer-based training and even also instructor-led training. But we're still waiting till these key points to implement interventions to change the content that they're receiving. Within simulation, what we can do now is adapt within the scenario specifically to how they're responding. So what we wanted to look at is in one training scenario, how can we adapt what they're receiving in the moment with all of the data that we're able to collect within simulation on their performance and attributes about their state. That's now within the realm of possibility. So you're measuring all this stuff. You may ask yourself, well, how do I adapt? Often what you see in traditional computer-based training, adaptive learning, is when someone reaches a pass or fail score that determines whether they move forward or they need to re-review the content. That's generally what we call rule-based adaptation, but there's also data-driven. Many people here know about ChatGPT and AI and machine learning that's growing so rapidly. And we could leverage those to figure out from a data-driven approach what this trainee likely needs to experience next. However, these require massive amounts of training data with the state that AI is in today. And for us to be able to really tie previous trainees and how they performed to new trainees. So there's challenges to both of these approaches, whether the cost is upfront or in determining what rules to use or in training different AI. So when we talk about when to adapt, generally these can be done on assessment or placement tests before someone even comes in to perform. So for example, we can adapt a course set that a trainee may get based on their placement exams. We may wait until they perform a specific task and determine whether they need to perform a remedial task or an advanced task after, or we can even do it during a scenario within simulation, again, which was our goal with this effort. And then we talk a little bit about going to more or less difficult elements. And when we talk about courseware and computer-based training, that generally makes pretty good sense. But when we talk about simulation, anything can be adapted. We can change the environment that they're operating in. So we can make for example, in different navigation style tasks, we could change weather, we could change states of the aircraft, we could change how many adversaries they're facing. We could change the level of feedback. Adaptive training first started by providing people tailored feedback on how they were doing and where they could improve. So we could change the levels of feedback that they get and when they get that feedback. We could change the content that they're presented with. So for example, if someone is able to pass certain routine maintenance procedures, we may move them on to more malfunctions or more rare procedures. And we can also change the pacing. So for certain types of skills where speed is a skill we would like to train, we can increase the rate of which we're presenting them with stimuli. And so there's a lot of decisions to make here right up front on what you're going to choose. There's pros and cons to each that are covered within the paper. If there's specific ones that you guys would like me to try and cover throughout this conversation, feel free to throw them within the chat. But what we aim to do here is create a test bed that would allow us to explore different strategies that can add to the science base, see what measures could be leveraged in a simulation environment as effective indicators of proficiencies and skills that could be leveraged by adaptation logic, and also to provide some guidance on in what ways should we adapt. So what we look to do in our initial development is stand up a rapid prototype that would allow us to collect various different inputs. So since this was a driving-based simulator, we built in the ability, which as John alluded to, in game engines, it's very easy to log various types of data, including how fast people are driving, how much they vary from the center of the road, how many times they go off-road, how many times just one wheel touches off the road. We put them on a very skinny and narrow road. And so there's a lot of variation in those inputs that could determine, in this use case, driving proficiency. Some are more sensitive, some may be more indicative of someone's skill, and some of them also have relationships. Likely someone is going to be a less stable driver if they're driving at higher speeds. So in this use case, since we were doing a proof of concept, we can take all of these different, what we consider skills and abilities, and build those into the test bed so that we can start to uncover which ones may be useful for those KSAOs. So what we did was build an first iteration of the test bed that allowed us to collect preliminary data. We used a more simplistic rule set using a matrix style approach. So not only were individuals driving along the road, but we also gave them cognitive tasks to perform at the exact same time, while John also covered they're wearing physiological sensors. So I'll cover that in a little bit more on the next couple slides, but basically taking a combination of their physical performance, their cognitive performance, and their physio states, and being able to create a matrix logic on whether their next condition should either become more or less difficult, or whether or not they should be provided additional assistance. So one of the benefits of taking this approach is you can start in this simple rule set, collect that data, determine if there's other things that you should be measuring and capturing, be able to identify where people potentially struggle, but that data can then also be used to train the models in AI so that you can pivot to that more individualized and effective approach down the line. So by using this sort of scaffolding approach to designing an adaptive system, you can start and see the values of where you're getting those and invest in them further. Since, as Jonathan covered, since we can stand up these test beds quite quickly in game engines, we can find the answers in an unclassified representative task, and then build upon those and transfer those lessons learned once we've found the solutions that we want to go after. So that's where we get to that redesign and refine. We may end up changing the thresholds for when someone gets more or less difficult content, or when the pacing or the feedback may scale. We may determine whether it should occur more or less frequently, and we may determine if other elements should also be adapted at greater levels. And I'll cover some lessons learned that we had in our first instantiation as well. There's a lot of other benefits that come out of taking this approach beyond the initial test set. So one, once you have a lot of this sort of modular framework within a game-based system, transferring it to another task is quite easy. So although we built this in a driving-based task, and you may
I
Did we lose you, Summer?
I think we lost her.
Okay.
So I think what she was trying to say was
all
the
right, good.
technical side of
You
things. When you
Yeah.
develop something like this, we develop it in modular ways so that we can use it within other situations. The code that we develop is all encapsulated, and so we can take that and drop it into any sim that's any sim that we've got, and it'll function the same way. It'll gather the same sort of data, take those inputs, do that same processing, then output that data in whichever form we're using, either like a CSV or a JSON, whatever sort of file format that we want to save this so that they can analyze that data later. Summer, you back on?
Yeah, can you guys hear me all right?
Yes, ma'am.
Cool. My headset decided to turn itself off. So next, what we can do is we can analyze the data that we're getting and further the adaptive training space by determining inputs. So I like to use this analogy of you have two different pilots, and let's say they're both just conducted one of their first landings on a runway. One pilot is very cool and calm and collected, and the other pilot was sweating like the guy from Airplane. Would you say that both of those pilots are ready to be pilots? You would probably argue you trust one guy more than the other. So when we talk about readiness, it's really a comprehensive picture of all of the knowledge, skills, and abilities. If we're not capturing all of those elements, then we run the risk of someone who's going out into the field who was not ready, or not capturing these key skills that we should be training and assessing at the training phase. Another example is if we were to take a medical scenario and we look at something as simple as sutures. Some of those important aspects are the spacing between sutures, the consistency of size between those, as well as the speed. When you're talking about a combat medic, you want to be able to take care of those pretty quickly, and you want to make sure you're doing both of those consistently. But if we only look at spacing as a measure of performance, we're missing out on other key aspects of a medic. And so when I was talking earlier about all of the driving performance metrics that we covered, we want to be able to ensure that we're capturing ones that are representative of what we would consider good driving performance. And so by exploring some of these within a lower fidelity game-based sim, we're able to advance the knowledge, skills, and abilities that we are capturing and build them into more simulation environments. Next, what we can do is we can use it then as a test bed to explore augmentation technologies. So one of the common things that we do within the grill is once we have stood up a test bed, let's start exploring things that may not exist yet out in the world. So for example, we can start to explore augmented reality solutions within virtual reality. A lot of people argue one of the reasons that augmented reality isn't instantiated out in the field yet is because the processing power is too low. It's not super visible in daylight, and it has a lot of tracking issues out in the real world. And we don't have to wait for the hardware to be developed to start understanding how these could help support the warfighter. So what we can do is start to explore if we find that training performance is starting to dip. Can we start to build in augmentation technologies that trigger within this game-based environment and see how they could support performance there? So going through this process isn't basically a full scrap. You can then still use it as a test bed to explore other technologies. Next, as I alluded to, we can take those lessons learned, transfer them to higher fidelity adaptive systems or live training. One of our challenges is always getting solutions into the classified spaces, into the training pipeline. So we can explore over in the R&D space, and then once we find solutions, apply them over the fence. And then lastly, we can find correlations among inputs. We unfortunately live in a world of constraints where we have either budget, logistic, or space constraints. So although we explored physiological metrics under this effort, it's not always possible that we can bring in Bluetooth sensors that send information into our training environments. So are we able to take physio data that we know is rich and provides us a lot of information and correlate it with something that can be collected automatically by the simulators? And so what we also look to do is find ways where once we find solutions, we can find these indicators. Can we provide basically instead of the 100% solution, the 80% solution that would allow it to be near close to the same level of effectiveness in a classified environment? So the paper that I presented at INSEG was the framework in which we had just recently finished collecting some of the data, where we were kind of at that initial design phase. We started with a simple rule set. We ran participants through. We're working on writing up those analyses now, so definitely stay tuned. But I'm going to walk through kind of how we built it out and some of the trends that we're seeing and some of the benefits of that. So in the grill, we always have a multi-spearheaded mission. One of those is, can we do something technologically that hasn't been done before? Can we do something that adds to the scientific research field? Can we also demonstrate the value to the broader defense community? So what we aimed to do under this was live connect physio sensors to a driving-based simulator that are read and logged with all performance metrics and can be used as an input to adapt the scenario. So can we take someone's physiological stress sensors and live change a driving scenario in the middle of it in order to calibrate that to someone's stress level along with their performance metrics? So then our other technological goal was, can we dynamically update the environment? So in order to keep that workload high, we layered cognitive memory tasks on top of that. We are always trying to help tell that story from experimental research where we're able to control all these variables and how it could apply to a more mission relevant scenario. So we built within the simulator not only the cognitive NBAC. For those of you that are unfamiliar, letters play out loud, and you have to basically press a button anytime that a letter matches the same letter played 2 back So in this example here on the slide, if a letter played F and then G and then F, you would press a button because the letter that was played to back was also an F. Very difficult to do. You have to keep a very running memory of all of those different letters. So that was our experimentally controlled. We also built within it a mission relevant task in which they have to respond to different alerts and beeps that come from their vehicle, to respond to basically IED warnings and incoming radar messages, and then also comms messages. So they would have to remember their own call sign, and when different call signs ask them for specific inputs, to execute those when it was time. So we were also looking to see if some of these inputs were unique to experimentally controlled settings and may not extend to the applied environment, and which ones may be more applied to the more mission relevant types of work. Because in some of our background research, we were seeing that the NBAC, although it's very popular within the cognitive workload experimental environment, it doesn't necessarily correlate physiologically with what types of stressors that military folks experience out in their day to day. So then we explored a couple of different forms of live adaptation. One of those being the roads. So sort of like an endless runner, road segments would spawn in front of you that were either more or less curvy. So people had to try harder to stay within the skinny road that they were on, while also maintaining a speed to rejoin with their convoy. Or we provided them multimodal queuing. So we looked at, for those that were struggling to balance the cognitive workload tasks as well as their driving, and their physio indicated to us that they may be a little bit stressed, we provided not only auditory assistance, but as well as visual assistance. So kind of starting to explore some of those operational augmentation strategies. And then one of the other very unique capabilities here, anyone who has worked with physio sensors before, being able to time sync physio data with sim events is huge. It provides a lot of benefit there. So all of that physio sensor data streams into Unreal Engine and is time synced with simulator events, which allows us to see specifically when a trainee is exposed to a stimulus, the immediate physiological response to that. A benefit to a small business that we were partnering with on this, which is NearSense. We took a gold standard heart rate band, which was the Polar H10, and their FNear sensor, which was a cognitive workload style sensor that we put on their forehead that tells you basically the oxygenation of the blood in your forehead. So the concept is basically if your brain is sending more oxygen to the front of your brain, you're thinking up quite a bit harder. So they had some algorithms within there to derive heart rate. So we were able to provide sensor companies with feedback on how well their novel sensors were correlating with physiological measures we were getting that are considered the gold standard. So it's also a test bed to then try different types of sensors as well. A lot of key benefits from this. So you may be asking yourself, well, can I use this test bed? Can we collaborate somehow? By all means, yes. Since we've conducted some of this research, we're collaborating with other folks out of AFRL and RHB, where they're looking to incorporate things like the Gallia headset that has EEG, as well as other analogous cognitive tasks, and being able to build in and explore some of their other or approaches. I'll pause here if we have questions.
Yeah, well, I do want to touch on just maybe some kind of encompassing versions, if you will, of some of the questions that were submitted ahead of time. We had several questions submitted that ask about the use of artificial intelligence in adaptive training. I keep wanting to say adaptive learning, adaptive training. How would you respond to that? Where does AI fit in on all this?
So AI definitely fits in. Since we were pretty much in our initial set phase, we do have a data set that could be used to train an AI that could be substituted for the adaptation logic. And that is something that we may pursue here in the future. I think one of the biggest challenges with when we talk about using AI is the challenges of making it scalable. We can take an AI, we can train it on a set of data specifically for this physiological test bed that we have. But how do we then extend it to the way that that AI may be able to provide value in other training scenarios? Um, there's so much power in the data and the way that we format it. And unfortunately, for us to be able to develop AI and I would say instantiate it at scale is to be able to ingest learning events from various test beds. And that's a big challenge in and of itself. So we have things like XAPI, which is a language that allows you to be able to communicate learning experiences. And so we could definitely build in AI in this specific test bed, specifically now that we have a massive amount of data from the first data collection. But also, as we look to scale adaptive training across the defense community, that will be a big challenge. So in some of my work for Aptima specifically, we're looking at building what we call the precision learning platform, which looks to create a ubiquitous system that can kind of pull in some of the different learning experiences, aggregate it in a way where the data can all communicate so that it can be accomplished at scale.
Curious too about some of the questions ask about the response of the trainee, the student that's going through these adaptive training platforms. Do you have enough feedback from your work so far to address that?
Yes. So specifically since we tend to play in the game engines, quite a few individuals found a lot of fun as it would continually get more difficult. And as they noticed that they put in incorrect inputs or anything, they would get a little bit frustrated, but also get motivated to do better. And so trainees responded pretty well. But what we did see was we were able to see that the simulator was accurately able to put people within their different skill levels. So they went through about 7 different trials. And so what we saw is that trainees were able to, by the end of their trials, end up where their current skill level was at. But what we ended up finding is that those who ended up in the hard condition had very, very narrow variance in their scores, which meant they all performed at about the same skill level. But what we were seeing for the individuals that ended up in the easy condition was that there was a pretty wide range in their scores. So again, one of those benefits to doing an iterative approach is that we were seeing that there's probably basically an easy plus that needed to exist as well. As we saw a lot of variance in the lower end of performance skills. So we probably had some people there that had very high error rates in which they needed that lowest difficulty, but there were some that kind of got stuck to where they, based off of our adaptation logic, could not move to medium yet.
And Jonathan, you mentioned Unreal as one of the key game engines that you use. Are there others that you have used or could be used in the gamification approach?
Yeah. We primarily use Unreal for the reasons I mentioned earlier. However, we have used Unity. It's a very popular game engine, probably arguably the most popular game engine. We stay on top of all the different game engines, but we find that pretty much all the other engines that are free and publicly available aren't up to the same standard of Unity and Unreal. They're great if you want to make a specific type of game. So if you want to make a side-scrolling game like Super Mario Brothers, or one of the more recent titles, if you know of any of those, Shovel Knight, etc., then like game engines like Godot are fantastic. But for 3D environments, the 3D just doesn't have the same level of graphic fidelity as Unreal Engine and Unity. And generally, it's accepted that Unity is for the equal amount of work, Unity tends to be about one step behind Unreal. You can get Unity to look beautiful with very, amazing visuals, but Unreal makes that a lot easier for quick development, which is, a lot of what we do.
Right. Thank you for that. One of the questions that was submitted ahead of time has to do with how DoD can adopt technologies from the gaming industry quickly to inject into training systems. And I'll just say that is something that is being addressed here in Orlando, and among the services that are here as part of Team Orlando, focused on training systems. And one of the ways that they've been utilizing us at the Central Florida Tech Grove to tackle that is each year we have at least one, and in some cases 2 game jams where the services, our Tech Grove customers, give us problem statements that are needs that they have in training, where they think adopting commercial game engine technology could be very effective in creating that trainings platform for that engagement. So if you're interested in knowing more about our game jams that we do, we'll be having our Armed Forces Jam in September this year, and we're actually looking at a slightly different variation of that with NATO in June that will be tackling modeling and simulation. So happy to talk to you about that. There was also a question raised about ethics when it comes to adaptive learning, because there's a lot with this personalization. There's a lot more information about an individual and how they perform, and you've got AI involved, which always raises questions. That's a big question. Who would like to make some comments about that?
So I'll go first, then Summer can give her view and opinion. Obviously, anytime that you're recording data about somebody, there's sensitive nature, right? But I don't think there's an ethical concern. I don't think that we have a moral obligation to do one thing or another. We're trying to get the trainee better faster, and that's our goal. It doesn't matter if we have to record everything about them to do that. As long as we get there, that's what we're here for. That's the whole point, right? So, I mean, the question about is it ethical to adjust training? I don't even see that as a question, honestly. I think that you already have training. We already do adaptive training. We just do it a lot slower, right? You go to the basic, you go to the intermediate, you go to the advanced, you have prerequisites for courses. Everybody went through college and they, there's prerequisites for what course you can take next. It's already there. It's just so slow that it's just obvious that it seems incremental. What we're doing is we're adapting that live so that those changes, if you're past basic, you don't have to sit through basic all the way. You can go straight to intermediate or to advanced. We'll drop you into whichever class you're actually ready for. And I mean, they have that in colleges. Again, you can test out of lower level mathematics into higher level mathematics from the day you get into the college. Oh, if you're ready for calculus or calc 2, you can test into it. You do have to prove your knowledge. Here, we just would drop you into a math class, and then as you were acing question after question, we would just ratchet it up until you were at the point where you didn't know the answers. And the challenge is getting the data from the user to ratchet it up to where they're supposed to be. And there's an ethical concern about storing that data, but we have standards for that. We have protections for that. So I don't think that there's an ethical question so much as safety concerns for the data, right? We want to make sure that if we store data, we don't want that data to be used against that person in a way that we didn't intend in the future, right? We don't want those sort of things to happen. I think for the most part, that's why we scrub different personal records in there, so that we just have this is the participant ID, and then everything else is obfuscated, right? So if you get that data and you get that participant ID, you don't necessarily know who that person is, right? So that's my take on it. Summer, you can give your your perspective, but I don't think that has major ethical implications.
Right. So I think the question was mainly targeted at the data, but I will say that there are some considerations when we talk about how it impacts workflow. And ultimately, for us to get to where our vision is, at least in the Air Force, for just-in-time multi-mission airmen, that we can deliver the right content at the right time for them to do skills that they've never done before, we have to track all this data. But when we talk about instantiating adaptive training at the schoolhouses, we have fixed timelines. They have a schedule in which they're supposed to move to their next base. And so there's really challenges with doing that unless someone's in the reserves. So if they were able to just basically complete their training and when they're done, they go back home, that works. But for a lot of people, that's not the case. They have a scheduled date that they're leaving their training base. So what do we do when someone's highly skilled? Do they just complete their training and then they just sit and wait to go to their next base? That's definitely one challenge. And then also if someone's not ready yet, what do we do in that situation? These are logistical challenges that really brings back to my point of adaptive training is so much more than just we're going to make content easier or harder. It's a complete ecosystem to adopt. It's a mindset to adopt. It's a data rich across the training pipeline that we need to adopt, but it really can give people those individualized aspects. One point I did want to cover that we uncovered in our first data collection is that although we decided to adapt multimodal queuing and road adaptation, we found that some people excelled pretty well on a couple of our metrics, but poor on others. So we intend to expand it to adapt specifically each knowledge, skill, ability, and other characteristic. So we can say if someone was struggling specifically at this, but really excelled at this, let's switch those individual knobs and give them the specific training scenario they need for their skills.
Where do you see this adaptive training and movement going? Do you think that eventually most training in DoD will be done using adaptive training? I say that because I know in some commercial sectors, we see personalized training, if you will, being used quite a bit on a different level. But is that where this is going, or will this be a training modality that will be used in certain scenarios and bookended maybe by live, obviously, on one end, and maybe some other form of training at the very beginning? Where are we going to go with this?
I would say that it's nothing is ever a one-size-fits-all solution. There's going to be situations in which nothing can beat live training. You can still adapt within live training. There's going to be situations where simulation is the biggest bang for the buck. You can do it more frequently. It's a skill that needs to be repeated in a safe environment, and simulation will allow you to do that. And there will be situations in which computer-based training is sufficient. It doesn't need to be flashy. And so I do see adaptive training being the way that we get everyone to the same level of readiness. So if we really want to be able to prepare our soldiers, our airmen, all of them as best as we can, adaptive training at the points where it's feasible is going to be the best approach. But it's on all of us within the industry to make that happen. We need contractors to be building in the data logging and the performance measurement into their solutions so that that can get passed along to the learning management systems that we're using, and the instructors to be able to leverage on their one-on-one time with the trainees, and so that the on-the-job training supervisors, when they leave the training base, can look back and leverage that and be able to give them the specialized attention that they need where they showed areas of deficiency, so on. So it's really on our software engineers to build in the data. It's on our researchers to find the effective strategies. It's on our instructors to keep doing the great work they're doing and finding ways that they can adapt in their short timelines in their training constraints. And it's on the Air Force to allow and encourage this type of ecosystem to be able to really fully build it out.
Thank you. As we wind up here, we're coming up to the top of the hour. Summer, Jonathan, thank you so much for joining us. All this great thought-provoking information. One last question for each of you to answer. If any of our guests here want to go educate themselves about adaptive learning, start really understanding the fundamentals of it, where are some good resources for them to go to get started?
Obviously, the paper that was linked is a good place to learn about some adaptive training. It points to a lot of great resources that you can read about the different strategies and different effective approaches. If you want to figure out how to collaborate with the grill, please go to the website, reach out to Premier John. If you want to chat about some more of our findings or about really anything related to the topics we talked about today, feel free to reach out. We'll also be at not only IT2EC, that's coming up here shortly to talk about data and talk about ways to interact in VR. But we'll also be at ITSEC as well. So we'll have this simulator set up probably in our ITSEC booth, and we'll also be presenting there on data as well. So look forward to seeing you guys soon.
Jonathan, anything to add?
Honestly, I think she nailed it. That's exactly it. Our website, we're always happy to talk about collaborations with people, and we really like getting good customer relations that we can leverage for especially our summer STEM program, where we can get the kids connected to actual challenges that people have out there that they need solutions for. So if anybody has or knows people who have these sort of challenges, we'd love to talk to them.
And if you're in the Dayton, Ohio area, feel free to come by the grill. We're located off base, so it's super easy to get to.
There you go.
Yeah, we can set up a tour, set up a visit.
And I recall it's fairly affordable to do work with you, right?
We try.
Time and effort is what it costs you, right? So, and energy, right? All right. Thank you all for joining us today. Stay tuned. Keep an eye out for information about the May Tech Connect webinar, which will be on May 18th. And we look forward to seeing all of you there virtually and hopefully in Tech Grove soon. Thank you again, Summer and Jonathan. Appreciate it.